Hello, my dear students. Welcome you all to Sri Jain Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, today we are going to start with a very important and interesting chapter, polymers. These compounds, they have contributed a milestone in the journey of chemistry. In this chapter, we will discuss different types of polymers, their classification, the compounds, they are of greatest economical importance. These compounds, polymers, they are of very huge or large molecular masses. So starting with the first slide, that polymers, they are the compounds. They are the compounds of high molecular masses formed by the combination of small structural units known as monomers, large number of simple molecules known as monomers. So we can say the polymers, they are macromolecules, and the building blocks of these polymers are monomers, which are micromolecules. Okay. The process by which monomers they combine to form polymer, simple molecules, monomers, they combine to form polymers is known as polymerization. Known as polymerization. Okay. The most extensively used polymer, and that too very common in our daily life, polythene or polyethylene. Okay. Now, all polymers are macromolecules, but vice versa is not correct. Mean that all macromolecules are not polymers. Like chlorophyll is a macromolecule, but it is not a polymer. Okay. But it is not polymer. Understood? Now, classification of polymers. Classification is being done on different bases. The first classification is based on the source of availability. First is natural polymers. In natural polymers, the building blocks that are monomers, they are of, you know, they are found in, or they exist in free state in nature. Okay. So these polymers are obtained from nature. They are obtained from nature. Like plants and animals. And we can consider biomolecules in this category. Okay. Are natural polymers. These polymers are very essential for life. Very essential for life. Understood? Yeah. For example, starch. Starch is a polymer of glucose, and it is a food reserve of plant, as you know. Glycogen, it is also a polymer of glucose. Okay, it is a food reserve of animals. Cellulose, it is also a polymer of glucose. The difference is between the stereochemistry of these types of glucose, the alpha glucose and the beta D glucose. Okay, proteins, they are the polymers of amino acids. Understood? Nucleic acids like DNA, RNA, they are the polymers of nucleotides. Okay. Proteins generally include the polymerization of alpha amino acids. Okay. It includes DNA and RNA. All these polymers which are found in the biological system are known as what? Biopolymers. Found in biological system. Found in biological system. They are essential for carrying out different biological reactions. Okay, they control different life processes. Different life processes. Next, semi-synthetic polymers. They are prepared in laboratories. Prepared in laboratories. Okay, but they have one or more naturally occurring polymers. Okay, so semi-synthetic polymers, they are produced in labs. Okay, when they are synthetically modified. Okay, they are chemically modified. They are synthetic modification of natural polymers to enhance their applicability. These semi-synthetic polymers include acetylation, acetylation of cellulose with acetic acid, known as what? Cellulose acetate. Okay. So acetylation of cellulose with acetic acid or acetic anhydride to form cellulose acetate. The reaction is carried out in the presence of H2SO4. Okay. The above reaction is carried in the presence of H2SO4, and the final product of the reaction is cellulose diacetate. Okay, cellulose diacetate. Cellulose diacetate is used in making thread and materials like glass film. Okay, then rayon, cellulose nitrate, they are also semi-synthetic. Okay, semi-synthetic polymers, they are mostly thermoplastic. They are thermoplastic polymers. Okay, cellophane is basically viscous rayon. The most important property of cellophane is it can be softened by applying glycerol, and it can absorb moisture, water. Okay, vulcanized rubber is also a semi-synthetic polymer. Gun cotton, which is cellulose nitrate, is an explosive. Is used as a explosive. Okay. Rayon is also known as artificial silk. It is prepared by treating cellulose with cold NaOH solution, okay, and then treating it with carbon disulfide to form a viscous solution. Carbon disulfide solution. Okay, and that is why it is known as viscose rayon. Okay, now rayon is used on the large scale to make textiles, tire cord, carpets, surgical dressings. Okay, it is a biodegradable polymer. Natural polymers are also biodegradable. Then comes synthetic polymers. They are having a huge list. Okay, they are prepared in laboratories and are called synthetic. Okay, they are completely man-made. No monomer or no polymer which is taken from the biological resource or the natural source is part of synthetic polymers. Okay, examples are polyethylene, polyvinyl chloride, bakelite, Teflon, nylon, etc. Okay, now the second classification we are going to talk about is classification based on structure. First, linear polymers. In linear polymers, monomeric units are linked in one plane. linearly. Okay, they are well packed and have high intermolecular forces. Okay, they have high densities because of large intermolecular forces. Their tensile strength is very high, high tensile strength. Okay, tensile strength means you can come up with change in the length of the material. Okay, so they are stretchable. Pulling strength, how much amount the material can be pulled off to change its length, and they have high melting point. Okay, examples of linear polymers. Okay, high density polythene. Okay, polyester, nylon, PVC, peroxyacetyl acetonitrile, pan, etc. They all are high in, we can say, the linear polymers. Okay, now the second category is branched polymers. Now the properties of the branch polymers are, okay, the monomers, they are joined to form long chains with some branchings. Monomeric units joins to form long chains with some side chains. Okay, or branches. They are irregularly packed, and that is why they have low tensile strength because of their random packing, low density, and low boiling points and low melting points. Okay, in comparison to comparable molecular masses of linear polymers. Understood? Now, low density polyethylene examples. glycogen, starch, they all are branched because they contain amylopectin. Okay. Then comes with the third category of cross-linked polymers. The monomeric units are basically cross-fitted or cross-linked together to form a three-dimensional network. Polymers. Okay, they are hard, rigid, and brittle. For example, bakelite, melamine, formaldehyde resin. They all are cross-linked polymers. When you will see the diagram, when you will see the picture of these linear polymers, cross-linked polymers, and the branch chain polymers, so it will look like that for linear polymers, the hydrocarbon chains, they will run like this. Okay. For branched polymers, contain some branches like this. But the two chains are not connected. But in case of cross-linked polymers, the polymerized tail, they are interconnected. This interconnection can be a disulfide linkage, like this. Okay. So these are linear polymers, branch polymers, and cross-linked polymers. The next classification comes which is based on type of molecular forces. So based on this type, they are elastomers, elastomers. They have elastic properties. These polymers have elastic properties like rubber. When these polymers, they can resize themselves, or they have a power of resiliency. When they have this capacity to return to their original shape, okay, after the strain is pulled off. So they have elastic properties, okay. most importantly, because of maintaining of this elasticity, resiliency, they should have very low or weak intermolecular forces. They have weak intermolecular forces. Okay, so because of these weak intermolecular forces, they can be easily come back to their original shape. Okay, example, natural rubber. Okay, a polymer of isoprene, polyisoprene. Then comes the second category, which is fibers. These are the polymers which have strong intermolecular forces. They have strong intermolecular forces. Okay, between the polymerized chains. The forces, they can be of hydrogen bonding or dipole-dipole interaction. Type of force, either hydrogen bonding or dipole-dipole interaction. Elastomers, they have weak intermolecular forces, which is known as what the London dispersion forces or the van der Waals forces. Okay, they have closed packing of the chains, mean closed packing of the molecules. Because of closed packing, they have high tensile strength and less elasticity. Their melting points are very sharp because of high tensile strength. They are long, thin, and thread-like. That's why the name fibers are given and can be woven into fabric. That is why they are known as what? Fibers. Known as what? Fibers. Okay. Examples are nylon 66. Okay. Nylon 66, Decron, silk, etc. They come under the category of fibers. Then comes the third category, thermoplastics. Thermoplastics, they can be easily softened by applying heat, soften when heated, and hardened when cooled. Okay. Although the change in properties is very minimal, change in properties during the softening and hardening, during transition, is minimal. Very less change in properties. Okay. The intermolecular forces are intermediate in between elastomers and fibers. Elastomers and fibers. Mean they have the intermolecular forces more than elastomers but less than fibers. Okay. No cross-linking between chains. Because of the softening, when the softening occurs as a polymer, the chain move and it becomes free. Okay, it becomes free. Okay, because of the absence of crosslink. Okay, so during softening, as they don't have cross-linking, okay, the polymeric chains they can move freely, and that is why they can change their shape. Understood? So whenever they heated, they become fluid-like, okay, and they can be molded to any shape. To any cast or shape when heated. Okay. Examples are polyethylene, polythene, then polystyrene, PVC, polyvinyl chloride, Teflon, etc. Okay. And the last is under this classification, thermosetters or thermosetting plastics. They can undergo permanent change when heated, permanent deformation. Okay. They become hard and infusible, and they cannot be drawn into any cast or shape on heating. They mainly consist of low molecular weight monomeric units, which can be semi-fluid in nature. Semi-fluid substance. Whenever they are heated, they get highly cross-linked. Because of cross-linking, the permanent deformation takes place, okay, and they become hard, infusible, and insoluble. Okay, cross-linking prevents the free movement of polymeric chains. That is why whenever they are heated, they undergo permanent deformation. Therefore, they are known as what? Thermosetters or thermosetting plastics. Okay, they are permanently rigid. Examples are bakelite, melamine formaldehyde resin, etc. There are important term, plasticizers. Plasticizers, they are the compounds which basically low down the melting point or the softening point. They reduce the melting point or the softening point of a polymer, but it cannot convert a thermosetter into a thermoplastic. Into a thermoplastic. Okay. They basically help to convert a hard or brittle plastic into soft and easily pliable plastic. They convert hard and brittle plastic to soft and pliable, which can be easily worked upon with the help of pliers. Okay. Plasticizers, they basically reduce the interparticle forces between the polymer molecules. They are generally esters, high boiling esters, okay, or high boiling haloalkanes. Example, PVC, polyvinyl chloride, okay, is a hard, stiff, and glass-like material, but after the addition of plasticizers like dioctyl phthalate, when added to PVC, which is a thermosetter, so, which PVC, which is hard and brittle, which is hard and brittle, okay, glass-like, converts it into soft and rubber-like. So these are plasticizers. Okay. Other examples of plasticizers are chlorinated paraffin wax, or plasticizer. This is also an example of plasticizer. Okay. So my dear students, we have done the classification based upon the molecular force, and then the classification comes based on the mode of synthesis. This is classification based on mode of synthesis. So based on this category, we have addition polymers and condensation polymers. Condensation polymers. Okay. Addition polymers, they are formed by the addition reaction, addition of repeated monomeric units without giving off any simple product or simple molecule, without elimination of any simple molecule like methane, water, ammonia. Okay. For example, when they are polymerized, this is polythene. This is the addition polymer. Then condensation polymers, in which the molecules are linked together by the elimination of simple molecule. Takes place. Okay, like HCl, water, ammonia, alcohol. Okay, examples of hexamethylene diamine when combines with adipic acid, both of, you can see 6 carbon to form nylon 6,6. Okay, this is amine, which is basic in nature. This is acid, carboxylic acid. So it undergoes condensation reaction to remove water. Neutralization reaction will take place, and the amide linkage will be there. There will be the formation of amide linkage like this. Okay, this is nylon 66. There are many more differences between the addition polymers and the condensation polymers. Like in case of addition polymers, only one monomeric unit is involved. Monomeric unit is involved. While in case of condensation polymers, more than one. Okay. In case of addition polymers, the monomeric units are unsaturated hydrocarbons. Having pi linkage. While in case of condensation polymers, they include the monomers having multiple functional groups. Addition polymers, they grow with the help of, or they follow chain growth polymerization technique. While in case of condensation polymers, they follow step growth polymerization. Understood? Then comes the last classification, classification based upon the nature of monomer. Okay, based upon the nature of polymers, nature of monomers, polymers are of two types: homopolymer and copolymer. Homopolymer when only one type of monomers are the part of polymer. Okay, example polythene. Okay, polyvinyl chloride. They all are homopolymers. Then copolymers, which include more than one type of monomers. They are also known as mixed polymers. As we have studied in the previous slide, the formation of nylon 66, okay, with the help of hexamethylene diamine and adipic acid. Okay, so these are copolymers. Okay, my dear students, we have completed the classification of polymers. We will be starting with the general methods of preparation of polymers in the next slide, next turn. Till then, bye bye, take care, stay safe, stay healthy.